All right, I guess we can get started. So I can start with just showing what's currently going on in the RetroGo project, because that's kind of interesting. So we have a branch where we are developing quite aggressively. It's a lot of new things that are coming there. It's the GUI branch. It contains code to load multiple ROMs, and it supports multiple saves and stuff like that. So I can just do a quick demo. So first of all, maybe I should show the difference in code. So you need to organize your project a little bit differently now. So you have a directory called ROMs with the NES and GB, where you put ROMs for each platform. And then for each ROM, there will be a save space allocated in the in the flash, external flash. So let me just clean up here a little bit and not use any copyrighted ROMs, because that's always a bad idea. Yeah, let's go for something. Here we go. So you simply put the ROM files. Oh, right. I actually made a mistake. Like always. So you put the ROM files. So now you have the ROM files in the ROMs directory, and then you have to run a Python script called parse ROMs. What this does is that it will go through the ROM files and create metadata and allocate it in the build system, basically. Yeah, that's right, JV Peak. It's the matrix animation is a Game Boy ROM. That's correct. It's actually open source as well. You can find it on GitHub. I can show it a little bit later. Yeah. All right. So let me switch camera. So here you can see the interface. All right, cool. So with the right and left arrows, you can switch between the systems, Game Boy and NES, and then up and down you can change ROM. Right now we only have one ROM. Then you can start a ROM either from beginning or resume a save. So let's start from the beginning. And now you can press here and either save and continue. You can also go into the options and change the brightness. We added this right now, so now you can do that. Volume also has effect. Scaling and filtering, we haven't implemented code to change this in real time. Speed works, and palette works. Yeah, lots of weird palettes. Usually, I honestly don't really know which palette you're supposed to use. I'm not that into emulation. I only integrate it. But it seems that the palette that is detected in the beginning, like when we load the ROM, is usually the best fit. Does it change the brightness in hardware? Or yeah, it does. That's correct. So when you change brightness, it changes the voltage to the LCD backlight LEDs. So it's hardware. Same, but unfortunately for the volume for the music, it does scaling in the samples. So the samples are shifted. So we lose one bit of data for each decibel. Like for each time we go, like the volume is basically how many positions we shift to the right. But yeah, it's a very simple solution and it's very cheap. Nice. So the way I change brightness, I can actually show that in the code. So let's think a little bit. Main GB, I think. It's funny. I wrote the code, but I can't remember where I put it. Maybe it's here. Yeah, right. So here's sort of the generic function that is being called from both the NES and Game Boy Simulator. And here is what's happening. So we set, there's a hardware peripheral, a digital to analog converter on the SoC or on the microcontroller. And we simply set a value to that. So it's between 0 and VCC basically. And this is real time, nothing strange. And there are no commands and stuff. This is pure voltage. Yep. So let's continue. And the speed up actually works in Game Boy as well. So now it goes in twice the speed, which might be useful in some games. Then if we do a save and continue or save and quit, we get back to our main menu, and then we can resume, and it will actually resume. And also if you press on the power button, it will go to sleep. But when you wake up, it will boot into the main menu. But yeah, eventually we will probably add code so that you resume the actual game you were pausing from. And then, let's go into the NES. And same here, you have the new game. And here you can hear the music. I don't know if it's loud, but yeah, there's music. Then you can turn it down, and it's more silent than before. And then you can save and quit, and then we can resume the Game Boy game, and it still works. And we can resume the NES game as well. So yeah, that's basically the current state of the GUI branch. And the last, so actually talking about drunk code, me and a friend wrote some scaling code that actually turned out pretty nice. So that is in the main NES code. So we tried to understand a little bit how the original firmware does it, because the Nintendo stock firmware does upscaling. And it turns out that it does the 5 to 6 upscaling. So for every 5 pixels, you upscale, you get 1 extra pixel. And it does so, or you can solve this in many ways. We solved it by using sort of a little bit of a cheating approximation for a perfect bilinear filtering. So let me just show you the tweet, because I explained this with a tweet yesterday or day before. So let's do like this. And I should show you my screen as well. That was stupid. So anyway, so here is a sort of spreadsheet view of pixels. So the idea is to show sort of a visual representation of how pixels map from the source to the destination. And this is the ideal perfect solution, where you're turning 1 pixel into basically one, let's say here, basically 5 units into 6, or the other way around. And this is all even and nice. However, we get a division by 5, which is very expensive to do. And also, there's another trick that I will show you. So this way, we get sort of a close enough, but not exact upscaling, but it looks pretty good. And now the really cool part is actually in the code, where we pre-compute. So my friend Linus, he came up with a kind of smart idea where we're using 565 colors, which means that every color or every pixel is a 16-bit value, which contains 5 bits for red, 6 bits for green, and 5 bits for blue. And the trick here is that we are spacing out each channel so that we get a 32-bit value that contains the 565 channels, but with a few zeros in between. This means that we can add the whole pixel with another pixel, and then we can shift right. And what this means is that we are operating on 3 color channels at once, instead of having to have R, G, and B and mask them out and then put them together again. So this way, we operate on RGB at once. So that's what so this is actually a 2-step thing. So here's the palette. So the source pixels in the NES emulator, it's 64 color values. It's just an index into a palette. So we pre-compute these spaced out values. And then here in the actual code where we blit or do the scaling, we do a lookup in our spaced out palette for the actual pixel that we're reading. And then we perform whatever we want to perform. For example, the scaling according to this scheme. And then with the conv, it's a macro that turns it back, the spaced out value, into a compact 16-bit value. And what this means is that this is not a lot of instructions. This is actually very fast. So we did some profiling and we ended up with the 2000 microsecond, which is only slightly, it's like, no, I don't have it here, but I think just doing the lookup results in like 1000 microseconds. So it's twice, it costs twice as much as just doing a sort of, just writing the pixels. So it's quite performant. So that's how the upscaling works. All right. So any questions? Just feel free to ask in the chat. So if not, then we can move on. So I wrote a hack a few days ago where I'm able to grab pixels from the device in real time. So I just want to show it on the stream because it's kind of fun. So this is in real time, grabbing pixels directly from the device. But it's not very fast. It's using the ST-Link right now. So I can show you how I do that. So it's this Python script. It even fits on the screen. It's literally not more than this. So I set up something called Video for Linux V4L2 device. Yes, that's correct. And then using this fantastic one-liner, I just ask OpenOCD to dump the frame buffer to a binary file. Then I write the binary file into the frame buffer of the Video for Linux device. And then in OBS, maybe I can, okay, this is a little bit scary, but let's try. So here is OBS, and I just set up a device like this. And as you can see, it works on the stream. But yeah, performance is not great because I'm using a cheap debugger now. Like if I use the J-Link, it's I think 5 times faster, but it's still kind of crappy. It's not 60 FPS, you know. And you get like tearing artifacts and so on. It's pretty crappy, but still, it's kind of fun. All right. Yeah. Then I also wanted to show off a ROM that someone sent to me. Vi Gray. Someone sent that to me. That's me. 1 second. I just have to download the ROM. Yeah, exactly. It's perfect for debugging because then you can open up the image and look at it in detail. So I have not tried out this ROM before. I have no idea what to expect, but this is okay. It's big. Have you made any progress on swapping out the EEPROM yet? Oh yeah, for sure. So I have a device here with a 16 megabyte memory. All right, here goes. I have no idea what to expect, but this is some ROM from the community. Oh, check it out. So I guess we can set the date. Oh, look, it's a calendar. Cool. I'm not sure if it can do anything more, but yeah. Cool. And it works. So as far as I understand it, this ROM has not been tested on the Game & Watch before. Discordian. Yeah, who knows? It's 24/7, always awake, right? Never sleep. All right. So with that out of the way, I guess we can start with the actual work that I want to do today, which is to implement a user interface library for the Game & Watch. But it will be more generic, and I'm actually going to start from scratch, like from zero. So I was thinking about preparing this and do some pre-coding, but meh. Let's do everything from start. So we need a name. So I'm thinking of calling it MUI, as in microcontroller user interface. So here goes. All right. EMUI is already taken. Okay. Well, the thing is that this will probably never be, you know, big in any way. So there's probably not an issue if there is a conflict. But yeah, it's stupid with the conflicts, of course. I suggest libembui, embedded UI, MBUI. Yeah. Yeah, GW, then it sounds very much Game & Watch specific, which for sure it is right now, but it would be nice to have it a little bit more generic. Yeah. MBUI. Yeah. Okay, let's go for it then. just gonna add the chat here. Welcome to the stream. Yes, we're just getting started. I did some, what's it called? Like a review of stuff that's been going on and so on. But yeah, we haven't written a single line of code for the library. That's now called libembui, as in embedded UI. So, all right. Okay, so we need some project structure. And 10 years later, yeah. Yeah, but MBUI sounds good. I mean, we can do a quick Google. Do we find? Wow, this is good. Okay, nothing. Perfect. Not even irrelevant crap. So yeah, that's perfect. All right. Yeah. But MBUI is totally different. Like this, how many percent? That's like the Hamming distance is huge, right? It's far away. Okay, so what do we need? We need source, I guess. So that's where the library source will be. And then we need a viewer. Maybe let's call it test or demo, perhaps. So in demo, we will write a viewer using SDL that will use the library to show stuff. All right. So should we call it mbui.h? Is that the entry point? Yeah, that would be fine. All right. So I was thinking of doing a higher level sort of overview of what we are trying to build, and using structs and APIs is probably a good way to do it. So yeah, let's start simple. So what should we have? What kind of prefix do we want? MBUI or something smaller, shorter? Yeah, sounds good. So I'm thinking this is going to be the main loop. So first of all, we initialize, set up some memory. So yeah. So and then we need to settle off. We need to decide what kind of struct style we want. Do we want, you know, this kind of style? Oops. Or this. So I don't know. I never really think much about it. I just go with whatever a project is using. So I think these are anonymous structs, right? And when you debug, it can be a little bit quirky. But with this one, you need to do like so. So I don't know. And you can also type def like so, right? So I don't know. Having seen a lot of C code that is basically 1 to 3 letter identifiers no one could possibly understand, I actually prefer long names, though I think some things can be reasonably short. Yeah, I definitely agree. But like I want to use like a prefix for everything, because then there won't be a clash. Like if you have rect or error or, you know, um, like if I call the function just, init, that will probably clash with something else. And for all the types, I probably want to use the prefix. All right. So for structs, which style do you prefer? Because I'm horrible at deciding stuff. So as long as everyone is happy, I'm happy. So like so. So should we go with the type def structs? All right. So usually you have a way to I'm gonna. So the idea is that this is supposed to be a user interface library, which means that we need to send events. So post event. Then we need a and this will be stuff like key button presses that will be handled. So we need a type for that. Let me know if the Discord link is broken. I'm actually gonna try it now. Okay, it seems to work. That's good. Cool. All right. Yeah, let's figure out what we want in that later. And then in run, there we will basically process the events and render. Cool. So this is basically it. What more do we need? We need some callbacks. That could be here, for example. Or we need to register some callbacks, perhaps. Yeah, let's think about that later. So what do we need? We need a renderer, right? So what is a renderer? That is something that can provide, it can take commands and change pixels on a frame buffer or OpenGL or whatever. So we probably need to initialize that separately. So here we can have stuff like color format. I don't have to scream. maybe some callbacks. So my idea is to have it separately. So you have sort of the high-level event processing, and that in turn, and you also add your nodes, your graphical nodes, that in turn are used by the renderer to actually provide pixels somehow. So I don't know. Which way do we want to do this? Maybe we should go from the depth first. So we start with the renderer and work our way up throughout the layers. But yeah, let's say we have a renderer that can operate on frame buffer, and whenever it needs stuff, it will issue calls to callbacks. Right. So now we have a way to render pixels. So then we probably need to run the renderer. So when you call this, it will change the frame buffer. So what is it rendering? We are rendering sprites, perhaps. Could be rectangles of solid colors as well, and stuff like that. So now we need some way to describe that. So let's create something. Yeah, focus on the renderer first. Yeah, definitely. Thanks. So question is, should we do some fancy stuff or just make it simple? So I don't want to do object inheritance in C because that usually ends with a, kind of a headache. Trying to do C++ and C, let's keep it simple. Yeah. So should we call it shape or rect? I think a rect will be fine. And a rect is basically it has a position, it has a color, and it has a size as well. Position and size and color. Right? That makes sense. And so the way I want to do this is I want to make it a back to front renderer which is sort of trivial. We are not gonna do something very advanced here. All right, let's see where we are in half an hour. See you, BMS. So we're gonna need some fundamental types. Yeah, what should we call a representation of a position? Is it pos? Just gonna copy this. And I'm gonna use int32 as sort of the standard type. All right. And what is a color? A color is usually, yeah, I mean, here we can do some cool stuff, or we can keep it simple, like so, RGBA. Maybe we want to revise this later on, so that we have a pixel format or color format inside of the color. I don't know. But yeah, here's sort of the highest resolution, like highest bit depth representation of a color. Yeah, so let's do it like this. So a rect again. This is, it has a position and it has a size, which is width and height. It has a color. Cool. Gonna split this up because I don't like when you have multiple things in a declaration. I don't know why I wrote that, but here we go. Okay, so now we have that. So for a sprite, what should we call that? Image. So instead of a color, it will have a pixel source. So let's call that asset. And then we need to define what an asset is. So an asset is usually, it should have a pointer to pixels. So the question is if we want to do something smart here, or if we just do like this. And then yeah, so an asset has a pointer to, let's call that data. Yeah, data, and it has a native size, the size of the actual pixels inside of the asset. And then we also need information about it, pixel format. Like how do we read it? And this could also be like if it's a PNG file, for example, we need to be able to load it and so on. But yeah, let's keep it simple. So for now, yeah, we just have a pixel format. So now we need a pixel format. That's sort of required. So what is a pixel format? Well, I guess an enum is the way to go. So I guess going for anonymous types all the way. Color pixel format. Image formats are quite advanced already. Oh yeah, definitely. So let's just call this pixel format RGB 565. That is the standard. And then we also have RGBA 8888. These are sort of the very standard pixel formats. And then we also, yeah, we should have a 1-bit format as well. Let's call that black and white, or mono perhaps, mono 1. So this is 1 bit per pixel, which is very good for text when you have a pixel that is either on or transparent. So that is basically alpha 1. But yeah, let's just call it mono 1. And then we have 16 bits per pixel. Yeah, this is trivial, but it's kind of... So one thing that is nice with RGBA 8888 is that you have 1 word per pixel, so that it's pretty fast to iterate over pixels. So if you have actually 24 bits, like, oh, maybe I shouldn't have equals 0. Then it's, you get unaligned reads all the time, which is kind of nasty. I could imagine doing as much as possible at build compile time. Yeah, for sure. But it could be interesting in the future, perhaps, to have PNG support, because those assets can be very compressed, like a lot. And then we can have quite rich graphics, stuff like, real images with the gradients, because gradients, they compress very well with PNG. But yeah, that's a future problem. Let's not focus on that now. But yeah, I think these color formats are the bare minimum. The RGBA 8888 will be very easy to use, because here you get the 1 byte per channel, so you don't need to do any masking. And the alpha channel is separate, and a gradient so that you can do smooth blending and smooth transitions. Okay, maybe pick from load PNG then. I took it for large boot splash screens in CBIOS. Okay, yeah, that's good to know. And my goal is that we can hook in basically any, so that a callback would be sort of a pixel provider, or you can have a pre-compute step where when the render engine asks for your asset, your callback is called and you perform the conversion. Okay, that's good. Good to know. Portable is nice. I want this code to be portable as well. So if you spot anything that I do that is not portable, let me know. But that's why I'm using these types, because they are generic. Yeah, here you have a pointer type because that is a native pointer, so that should be fine. Yeah. Anyway, okay, cool. So now we have pixel formats. So let's use that. So now we have a way to represent an asset. Size. So size is not really, we should also have stride. So an offset, yeah. Offset and stride. So that we can point into an atlas. And yeah. So in case you're not aware, because I guess there's, not everyone knows everything here. So let me explain why this is needed. So if you have an asset atlas, that is, for example, if you have a bunch of different images bunched together in one big image, then using offset and stride, you can, or actually this should be a size. Let's call that, yeah, basically you can crop out stuff from an image, from a larger image. So maybe we should have some sort of representation of x, y, and width and height as one type. What should we call that? We can use that for clip rects and stuff like that. So basically, if you have x, y, or maybe you should have a position, and then you have a so I mean that's actually a rectangle. Yeah, what should we call this then? A rectangle, a colorized rectangle. Naming is hard. That's basically 50% of the work, right? Yeah, naming is hard. So a position and a size, that is a rectangle. Yeah, let's call this a shape instead. Yeah, and then we can have a different shape type later on, like a rectangle or a circle and stuff like that. That's nice. Okay, so we're going to use the rect to talk about our location. So location and size. Yeah, so I guess we can call it rect. Yeah. And that also goes for the asset. So let's call that clip rect. Or maybe that will be confusing. source rect. Yeah, okay. So my idea here is that you have a pointer to some sort of pixel data in some sort of pixel format. Then you have a location, x and y, and a size with a height, which is where you want to copy pixel data from. But then you also need a stride. The stride tells you how much you have to iterate on the x-axis to get the next pixel. Yeah, I think this is good. So what is an image again? Yeah, let's use the rect again. So an image is a rect with an asset. And then we could have blending options and lots of fun stuff. But yeah, essentially, yeah. I'm just thinking a little bit. I'm gonna need a magic in the beginning. So basically a class, this ends up like a class system anyway. Fuck. I wanted to avoid it, but it's stupid to not use it. Like, it would be nice to have, if you think like object oriented, everything is renderable, but you want to know how much you can unpack. So essentially, when you want to put stuff in the tree, yeah, okay, so now we have the primitives in place, and they make sense. We have a rect, everything sort of, the lowest primitive is a rect, and then on top of that, you can customize it. So for example, the shape, it has a color, but maybe it makes sense that the image also can be colorized. So yeah, let's use the shape instead. So an image is a shape with an asset as well. Okay, cool. Because that means that we can render shapes. That is the lowest primitive that we can render. I think that makes sense. So this is like the base class, so to say. Okay, so now that we have this, we need some sort of tree structure for the rendering tree. So what exactly are we doing? So I'm thinking of having a very naive back to front rendering where we have a linked, or actually, yeah, I guess a linked list will be the absolutely simplest way. So imagine if you want to render, a background image, and then on top of that background image, you want to render two smaller images. Then you basically have the background, and then you have the image 1, and then the image 2, just like a linked list. You start rendering here, and then you just jump to the next and to the next. Very, very, very simple. If you want these images to be rendered on top of each other, the order is simply the rendering order, in which order we render them. So this will be the absolutely simplest way to do it. Then we don't have to worry about tree structures. So let's create a node. So what is a node? A node, can you do like this? You have pointers to the next and previous, and then you have some sort of data. So yeah, this is when it starts getting scary, because you don't know the size. So yeah, let's use pointers. So, and this will have to be casted to whatever shape you're using. So I guess yeah, we're gonna need some sort of node type in the beginning, and then whenever we create some sort of shape, we need to initialize the type. So let's do that. Let's try to collect the enums in one place and the structs in another place. So, oh, there we go. And there could be more shape types. Yeah. Okay, now we have that. Okay, so what now? So now we have a linked list and shapes. Cool. Now we need to set a root of the tree. So my idea with this is that we are not going to use any dynamic memory allocations at all. So the caller has to manage memory. Okay. Cool. So I guess we can create some macros to initialize different shapes. Doesn't a linked list make it quite tricky to delete an asset, though presumably also tricky to manage Z order? Yeah, so like I explained before, this is 100% up to the caller. The application will have to handle this. And it is not that tricky. You only have to move your node. So you remove it from the linked list and then you insert it somewhere else. That way you change the Z order. And I think that shouldn't be too hard. I can create some convenience functions for it. But if we want to keep this like a bare minimum, super simple, not trying to do something too advanced here, then I think this will be good enough. Obviously, a back to front renderer is not optimal. Like if you have overlapping, let's say you have 5 images that are overlapping, then performance-wise, it doesn't make sense to render any of the overlapping pixels or the pixels below the topmost layer. So you could optimize this in many ways, but I don't want to focus on optimization now. We can do that later. So we can of course have a tree structure, but that will take time to implement, and the linked list is trivial, at least to me. A tree structure will be a little bit more complicated. So let's do like this. Do while 0 and can a caller insert an asset into the tree? Yeah, I'm thinking so, yeah. That's the idea, I think. So, I mean, we could write this library so it's very safe and nice sort of experience to use, but I want it to be kind of raw and simple. Like I'm thinking of be able to finish this code within like less than say 10 hours. I don't know. So I'm hoping we can get like a rectangle on the screen today. I don't know really exactly how long that will take, but I want to like design the structure first, and then we can start implementing stuff. But yeah. So how do we init a shape? Well, we take this dot type equals I don't know, maybe this macro doesn't make sense. We can always remove stuff. Yeah, let's do that later. But I guess in the end we will have macros to initialize all the different types of shapes and so on. Let's not think about that too much now. Okay. So again, now we can set the root of the tree. We can render the tree. We can initialize the renderer. But can we actually do that? We need, now we have a little bit more. So we need some sort of frame buffer. And we need a pixel format. So this is really the bare minimum. So you get the frame buffer and you get the format. I think you should perhaps know about the size, so you don't write outside. So let's create a rectangle for that. What should we call that? Active area. Is that clip perhaps? And then the native size. Let's just call it rect, like I did for the asset. Source rect stride. Maybe I shouldn't use stride. I should have like a native rect. Does this make sense? So the idea is that this is the size. No, that shouldn't be a rect actually. We should have a native. We should have a size basically. Yeah, we should have a size. So this is the size of the asset, the native full size of the image, and source rect is what you're copying from, right? Maybe we can. I'm trying. I want it to be as I don't want it to be confusing. Does pixel format and size imply stride? Yes, exactly. Exactly. But yeah, let's call it source rect. So the idea is this is what you're this is the area you're copying, the interesting area, the source offset and with an height. Cool. So let's do the same for the frame buffer. Where was that again? Here. So size is the physical size of the frame buffer. And then clip. Yeah, I don't know. So I don't want to over design because that is really, really dangerous to do. Source rect is what I'm familiar with. Yeah, perfect. Nice. So you could have a clipping area so that you are basically disallowing pixels to change on the outer borders. But you could also, for example, yeah, so this would set origo to something else. Yeah, so imagine that you have 320. So maybe I want to paint something. I have a drawing tablet, but no good way to show it to you. I have this Remarkable too, but the remote sharing is not working very well. So I'm just gonna open up GIMP. There we go. So all right. So imagine that you have a frame buffer. How do you draw a shape? Oh man, I'm so bad at this. Where do you have a rectangle? I can't find the rectangle. Okay. So imagine that this is the actual frame buffer. And then this is the active area that you're allowed to write to. Then this position is your origo. That is the 0, 0 position, even though this is the actual 0, 0 position. So when you say, I want to paint something at position 0, 0, then it will be in this area. So I think that makes sense. You can select an area and fill the border. Okay, I'm really, really bad at GIMP. I grew up with Photoshop, and after I moved to Linux as main OS, I haven't been using Photoshop for a long while, but I miss it ever so often. Anyway, draw.io. Yeah, that's actually not bad. Thanks. Maybe I should have a scratch pad over there. Okay, here we go. Yeah. So, but yeah, you got the idea. I hope. So yeah, but you got it. So that this is the actual 0, 0 position in the frame buffer, and this is the origo of the active area that you're allowed to use. So that when in the rendering engine you ask to paint something at 0, 0 when with height 100, 100, then it will be starting here. So it will be like this. How do you fill it? You can fill it. Yeah. So there we go. So I think that would make sense as an API. cool. Yeah, so we have the frame buffer, or let's write frame buffer so there's no ambiguity. So you have the size of the frame buffer, and then you have the clip area. Yeah, let's call it active area. Okay, cool. So I think we're pretty far now. So again, we can set the root. We can run, which will render one frame. Init will perhaps configure some internal states, because later on we probably need to have some internal RAM state that the renderer needs to be able to change and so on. So it's always good to have an init function. Set root. Okay, I think this might actually be enough. So yeah, and you need to 100% manage the nodes, and each node contains previous and next. It has a shape, and each shape has a type, so it can be either just a shape or an image, and it could be other stuff as well. Yeah, maybe this is enough. So what we could do now is that we implement these functions, and then we can paint pixels on a frame buffer. That would be pretty cool. So let's let's fix this a little bit. So when you do init shape, you set the type to this one, and then you need to set some stuff. So what do we have in shape? We have the rect, and in the rect we have pos and size. So let's not call it X, let's call it shape. And color. You know what, screw this. This is just gonna, no. You have to do this yourself. Okay. The events, did we? Yeah, let's not care about this right now. You can just comment this out for now. Yeah. So let's write some code. So we're gonna need a C file that includes the header file, and then we need to implement the functions. And maybe we should have return codes. That's always a good idea. So what kind of return value do we want? Signed integer, then we can have negative values. Or should we call it EUI RT? Does that make sense? Then we can just, like so. Or it's the other way around. I always mix up the order of the type def. I don't know why. It's just how it is. And then we can yeah, there are so many ways to do this. You can have an enum, you can have a defines and stuff like that. Should we go with enums? Maybe we should go with an enum instead. Let's do that. And let's call it okay is 0. And then I don't know. There are so many ways to do this. I don't know. Let's think about this later. I just want to have a structure in place so that we can start working. So let's start with init. All right, I should probably have a prefix. That's always good. So init, it just doesn't do anything. Run, that will be interesting. Set root, yep, it will. Oh yeah, we need to have a root pointer. So now we could have sort of pimple sort of structure, but we don't need to hide too much. But we can make a clear boundary. So let's call it like so. So this is like the private stuff that you shouldn't touch. So let's have a node. Okay, so now we need to move this a little bit down. We need a node that we call root. Okay. So now we have a root node. Oops. And we have our private data. Yeah. So the idea is that the user is allowed to change these things, but this they shouldn't touch. Okay. Yeah, that was easy. Then of course we could do some sanity checking and blah 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 blah. Maybe we should have assert. I like assert. But yeah, I don't know. That's gold plating. I'm really bad at knowing when to stop with over design. But if you tell me in the chat that I'm doing stupid stuff, then just tell me. Okay, so we set the root and run. So here's the renderer function. This is where the magic happens. So let's close this and open up the header file to the left. Yeah. So again, this is sort of the API, and this is the code. So let's create the node. Yeah, we have a node. Oops, what did I do? Right. So while node is not null, then finally node next. So this is what I mean. This is very simple. Oh, where does null come from in C? Right. right. Okay, so we walk the linked list from beginning to the end, back to front, and we need to render. So the question is now, how do we render? How do we want to perform rendering? So there are so many ways to do this. Many ways. So we could have render function per node type. That in turn checks the color format of the source and destination and stuff like that. I guess I can just write some code and we can just get a feeling for it. So one way to do it would be to ask the node to render itself with our context of the renderer. This is one way to do it. Look how simple it is. It's really extremely simple, right? This would essentially be all of the run. Yeah, I kind of like it because it's so simple. But yeah, of course you need a dereference here, and you jump into this function wherever that is. Or you have a function that checks what kind of node type it is and renders based on that. So maybe that is better actually. So we yeah, there are again so many ways to do this. So if we do it like this, then we need to set the render function when we initialize the node. Welcome back, BMS. So let's. I can just do a quick recap because it's helpful for me as well. So we have basically written a header file that's starting to look pretty decent. So starting from the end or the beginning, however you want it, we have an API to initialize the renderer, which doesn't do much right now. We can run the renderer, which will render one frame. And then we have the setRoot function, which will set the root of the render tree. And the render tree in question is a linked list that renders back to front in a very trivial way, nothing fancy. Yeah, so the way it's set up is that we have a frame buffer format, the size of the actual frame buffer, and then an active area, which could be a smaller area of the frame buffer in question, so that you set the origo and the maximum width and height, which can be useful. Yep. And then about the nodes, there we have something called a shape, which is sort of the base class, which contains a type information as a enum. It contains width, height, and or x and y and width and height, something we call a rect. So a rect has a position and size, like so. And then, yeah, that's a shape. And a shape could later on have some sort of actual shape definition. Then we have something called an image, which is a shape, but it also contains asset information. So an asset is some sort of data together with some sort of format. And the pixel format, right now we have only defined the 1-bit mono, which is good for fonts, like very simple fonts. Then we have the 565 standard, and then RGBA 8888. And the reason for this format, why I like it, is because you have an alpha channel that is 8 bits, and then you have all the color channels as a byte, so they are very easy to access. So for example, if you have a transparent image, a semi-transparent image, you can blend it very nicely. So for example, imagine if you have a, what's it called again, a gradient. You can go from, transparent to non-transparent, and it will look very nice. Yeah, exactly. Then we have, oops. Yeah, so that's a shape again. No, sorry. Right, an asset. Yeah, so an asset is pixels in some sort of format. And then you have a size of the actual asset, like the actual underlying pixel data. And then you have a source rectangle in that data. So again, I think this illustration will help. So imagine if this is your image in your Flash, and then this green thing is the image you want to render. Then you set the source rectangle to this position and width and height inside of the big width and height. So yeah, I think that makes sense. So that's an image. And then we have something called a node. And a node is an entry in our tree structure. And currently the tree is a linked list, so it's a flat tree. So you just have a beginning, a root, and you just iterate it one step at a time. And why I do it like this is because it's simple, trivial, easy. And if you want to render one asset or one shape on top of another shape, you have to make sure that the topmost comes after the one below. The side effect of this is that you can make sprites animated simply by offsetting the source rect. Oh yeah, exactly. That's a really good observation. I didn't think about that, but that's definitely true. Okay, yeah. So that's basically the header file. So that is our, as you say, foundation. So now I'm starting to like dry coding this. So currently we don't have a build system, we don't have a makefile, we don't have anything. I'm just writing code. Have never built it, but Visual Studio Code is helping me a lot. Like it does these red squiggles. So I think actually this header file will compile because there are no syntax errors. So anyway, so right now we're trying to decide on the strategy for how we want to render. So again, you call init, which doesn't do anything. Yeah, I mean, I'm super happy with the Visual Studio Code as well. It's really decent, so to say. It does a lot of good things, but it's not perfect, but it's better than a lot of things, and I like it. Okay, so you set the root to something, and then you render a frame. And we render a frame by iterating a linked list. We start with the root, and then we render the root, or then we render the current node, and then we set the node to the next node until it's null, and then we're finished. That's it. Eventually, this will of course become more and more complicated as we have events and animations and stuff like that. So something that I definitely want to implement later on is a animation system. We can talk about that later. I have a lot of ideas for that. So if you want to have if you want to move stuff around on the screen, and if you want to have easing curves and stuff like that, we can do that. That will be very easy to do, and or yeah, perhaps not very easy, but I definitely know what I want to do. So yeah. So now the question is, yeah, exactly, yeah, and I've done it before a bunch of times, so I'm not afraid of that. I see no issues with it. Cool. So now about the render function. So one strategy is that each node knows about its own render function. And the render function has to know about the source format and the destination format, and if it has to blend, and if it doesn't have to blend, and so on. So, for example, if your source format is RGB 565, then it can like write directly to the frame buffer. But if the destination frame buffer is of this color format, then it has to do color conversion and so on. And all of that stuff needs to be handled in some way. And you can do this in many ways. So yeah, one way is that the node itself, or either the node or the shape, is aware of this, or that we add some code here to check that and use the appropriate function. So the drawback with having to look it up every time is that, yeah, you have to look it up every time. And right now it will be simple because there's not much to look up. But later on, maybe it will be faster to have a function call or not. So I honestly don't know. Maybe we should just do the lookup every time, because it will be a very fast lookup anyway. So let's scratch this and implement it. So we pick out the shape and we check the type. Oh. Yeah, so the idea with the prefixes is that this library should never clash with anything else. That is the idea. So that if you import this header file, you might have like an RT or a node T or whatever. Okay, so now we have the basic shapes. We have either shape or image. So let's start with shape. So yeah, I wonder what is the best way to do this. The shapes are easy because we only need to look at the destination color format. So we can actually pre-cache that. But yeah, we don't need to do this hyper optimal. Just like so. We can switch on the destination format and do yeah, what would we do here? We want to do so now we want to call an internal function, non-exported. So should I just call them underscore? No, let's call it render. Oops. Render shape. Mono 1. So no, actually, let's only focus on 565 as a destination format. And then we need the renderer instance because it might be good to know to get the frame buffer. I love how I'm able to follow your journey with this. It's lovely. Yeah, perfect. That's great to hear. Because that's also why I didn't do any homework, so to say. We're starting from zero. This is nothing is done in beforehand. Like I've thought about it a little bit, and I've worked with stuff like this before, but this is starting from scratch. And you are along here. You can tell me to do stuff or ask questions and so on, and question. Like if I do something strange, you can just say, "Wait, what are you doing?" And I will listen to you. So yeah. So we need the node, and I guess we can pass the shape. Yeah. So this is the basic stuff. So now we can draw a black rectangle over the whole screen, and then we can draw a blue rectangle at some position. And they should be rendered in the correct order. Make sense? So I can put it here. Yeah. Okay, so this is, let's think again. I think, yeah, I have a color. And the color has an alpha color or alpha channel. So here we can do something very simple. If shape color dot a is, should we have some definitions? So I want to have something that is defined as OXFF. But I need a name, and I cannot come up with a good name. So if somebody comes up with a good name for this one, then let me know. So we're going to create a 565 color using yeah, so I'm going to try to write this as readable as possible. So now this is going to be a little bit icky. So first we mask out. All right, we're going to go in that direction. So RGB values are stored in 8888. So this might be a bad design decision, that maybe a color should contain like a native color and like a, yeah, but we can always optimize later. So let's start with the basic. So I'm thinking like, should I pre-compute the destination color, stuff like that. Yeah, you can do that, but you don't really have to. So let's just open up Python because that's always good. So this is the max color value of an 8888 color because it's 8-bit, and we want to mask out 1, 2, 3, 4, 5. So this is the mask that we are gonna use. That is OXF8. Okay. Yeah, and then we OR this together with the green color, and we need to shift it as well. So opaque. Yeah, that's what I'm. So that's what I'm checking here. So I can actually make a comment about that. So that is when it is fully opaque, we can just write colors. But if it's less than OXFF, then we need to blend it. So how many positions do we need to shift this? So we have 16 minus 5, so it's 11. And then we need to do like that, FC, and then we shift that with 5 positions. Oops. And then finally the blue one, we need to shift that to the right. Just thinking if I'm doing this right or not. We need to shift this right by 3 positions. Does this seem correct? So it was actually a while ago that I wrote stuff like this, so I'm just gonna check this with Python. So let's just do like that. And then okay, so this is too much. So I need to shift this right as well. Oh, this is gonna be nasty. I guess what I can do is to just shift it right, or shift it left with fewer positions. Right, so I mask out the MSBs, and then I shift it left with whatever is left. So I have my 8 bits, right? Math on stream. Please don't judge me. This will take a while. So let's say we have OXFF, and we mask it with OXF8, right? And then we take this and we shift this. With 8 positions, right? Because now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Yeah, exactly. Yeah. So here is the red channel, and then we have the green channel. So this one we need to shift 2 places, and then we have 1, 2, 3, 4, 5. Yeah, exactly. And then this one we can just shift right immediately with 3 places, right? We go from 8. Yeah, exactly. So yeah, this should be right. So I'm just gonna update this 8 to 3, and then remove that, and yeah, that should be it, right? And add those as well. So here we go. So this is what we want. So if I set r equals 0 and g equals OXFF, and we do the same thing. It's off by 1, of course it is. So that one should be shifted with 1 extra position. But this is why you test it, right? So here you go. Yeah. And then the blue channel. Right. Just double checking. Yeah, looks fine. Cool. So I just want to be very like thorough with what I'm doing, so you see what I'm doing as well, and I'm not like, you know, just writing code and then maybe people won't understand. But here I'm trying to go through each step so I'm clear and so people understand what I'm doing. So yeah, A33, perfect. So now we can understand that. Pixel soup, exactly. And yeah, this can be a macro because we're gonna need this as well later on. But yeah, let's skip that for now. Yeah, so here we are in the special case of opaque color, where the destination is RGB 565. So how do we do this then? So now we need a while loop. So we will be operating in the destination frame buffer. So our starting position, like you can optimize this a lot, but let's just make this simple. Yeah. So we want to start at the where are we? Maybe we can pick out that. So we go to the renderer, we ask it for the active area. And the reason for this is so we know where we are going to render. So area dot post dot y. This is the starting line. Hello from Germany. Hi, welcome. And we want to render. All right, we need to do a lot of more stuff. What are you programming? Yeah, so this is beginning of the journey of UI rendering engine. So we are starting from scratch, writing everything from scratch, and it is meant to run on Nintendo Game & Watch. So it's a microcontroller, which is kind of fast, but also kind of limited. So we want to keep it simple. And this is both fun and useful. Like we need it, but we could also use some pre-written library, but that where's the fun in that, right? So yeah, that's what we're doing. So again, we're not writing optimized code. We are starting simple. So we have a start x and start and end x, and then we have a start x and an end y. Sorry. So basically the same. So for y equals start y is less than end y plus plus. And in case you're unfamiliar with graphics code, the reason why you go row by row and then operate on the columns is because the memory is layouted that way, and you want to access memory linearly and not jump around. All right, and this is the 565 function, so we know stuff about the frame buffer. So we know it's a uint 16. So we can do this. And then we can do slight optimization where we do like this, where we, for each row, we look up where we want to go. So we go y times area dot size dot width. So again, this is what we normally call, oh, this is actually wrong. So let me tell you what I did wrong here. So now we want to know about the stride and offset in the frame buffer. So as I explained before, we have the frame buffer definition here, where we have a size and an active area. And again, the size is the size of the frame buffer, and the active area is where we want to paint. So let's take that into consideration. So the stride is actually, let's do, or actually, let's call this FB size. Right. So again, Visual Studio Code, thank you. So it complained that the types didn't match because this is a size and this was a rect before. So here we have the FB size. So we want to find the offset. We're operating at pixels now. So we want to know how many bytes or how many pixels in the frame buffer do we have to go, where is our starting position. So we need to take this, which is the y position of the active area, times the full stride. Then we need to add this offset. So let's do that. So we take, first of all, we need to take the offset. Actually, we can, no, let's make it simple. Yes. So again, FB is the pointer to the full frame buffer. So let's add the row. So we take FB size dot width. This is our stride. We can actually store that. We call that stride because we are going to use that again. So we have this stride, and we need to know how many rows we need to skip. So we take the area dot pos dot y. So this tells us how many pixels do we need to skip from this position to get to this position here. And then we need to add this, which is area.post.x. But then we need to add the current row. But now that I look at it, I'm not talking any sense because I've already added the position. So scratch everything that I said and let's just use y directly. And let's say y times stride plus nothing. Actually, we can plus the start x. Yeah, no, again, my head is like trying to optimize always, but I shouldn't. Let's make this simple. So here we get a pointer to the current row in the destination frame buffer. So nothing is, so we're just skipping ahead. And then in the x for loop, we have to know how many pixels in x-axis we are gonna skip. So yeah, sorry for the mess, but I'm also, when I'm streaming, I tend to become a little bit stupid. Sorry about that. So here we have again row UN16. So this is a pixel buffer for the current row. Yeah. And this is, yeah, this should be correct. So here we just paint it with the color. So raw color. So this should technically be done. So now we should be able to render basic rectangles in 565 mode that are opaque. So we could run this and test it, but we could also implement blending. But yeah, let's start with this. I want to do everything, but I need to take it one step at a time. So, are you seeing anything strange? I'm always ready to test when I do something. All right. Yeah. So let's test it. So we need to set up a simulator environment. So we have this demo folder. So again, if you have any better name, now is the time. I was thinking about test, but test is usually for unit tests, and this is not a unit test. And demo is sort of it's good. I think it's good. So let's go into demo. Oh, and create main.c. Every project needs a main.c, right? And here we do include embui.h. And we need a makefile. And I am really bad at makefiles. Writing makefiles from scratch is not my strong suit. So actually I'm gonna use this one. So I wrote a simulator for the Game Boy or NES emulator for desktop in order to test the emulator before. So in case you're not aware, you have this in the Linux directory where okay, it doesn't build anymore. Sorry. It used to be able to build, but not anymore apparently. Yeah, I'm just gonna copy this and simplify it. Okay, so let's call this demo. And this is really good to build with the address sanitizer on desktop because, yeah, you never know if you have memory issues with overwrite stuff. So C sources, this one will be extremely simple. We have main.c and we have embui.c. Yeah, we don't really need these. Yeah, we don't really have anything defined. We want to include the current working directory and oops, and source. So this is the current directory and this is the library. Yeah, we will need SDL. Yeah. And maybe we can remove some of this stuff. I don't know. All right, so this is without ASON, and this is with ASON, or ASON, however you pronounce it. Right. So here we have the dependencies. So if you change the make file, the build will have to be rebuilt. We rebuild it, and then we show the size. We don't need that. And here is the dependency. So if you change a header file, it will rebuild. Okay, I believe this should work. So let's continue with the main function. So again, let's steal some code. So we need to initialize the window and finish with the STL quit. So as you can tell, I don't like to write code that I don't have to write. We want to work in 565 mode. So yeah, I'm not focusing on explaining what all of this does because, yeah, we're just setting up a STL context. There's no magic. And audio, I mean, we could have audio. That could be interesting, like if we want to have button presses. But yeah, you're right. Let's skip it for now. Let's skip that for now. And then we should have some blit function somewhere. This, yeah. That's a lot of code. We don't need anything of this. We only need this. So while true. Yeah, exactly. So we have the native frame buffer. Actually, how does this work again? So this emulator, it converted from a LUT-based pixel to 565 data. But now we don't really need that. Do we need... We can skip this one, right? The update texture and just write into the FB texture. No, you're right. We need this one. Okay, cool. So yeah, you're right. So let's read the docs. Okay, let's do this. So I'll just put everything on the stack for now. Yeah, I tend to forget everything about SDL whenever I stop using it. So again, we set the frame buffer to FB data. we set the size to be, or actually we can do like this, width. Actually, we can do this nicer. Okay, so let's memset render priv with the zeros. So that in case you have a stack data, you might not have it initialized. Cool. So now we have the renderer initialized. Cool. So now we we have to set the root. And in order to do this, we need to create our tree. Okay, so just thinking a little bit. There are many ways to do this. I'm thinking of writing a convenience function because this will be a bit repetitive, I think. So first of all, I guess we should create our shape. Let's call that shape background. We set the rect. Yeah, as you can tell, this will be very repetitive. So let's make a macro. I actually removed it. Damn it, that was stupid. So now I'm gonna make a macro. Like so. And let's just write everything we need. And then we need tons of these. So let me just steal some code. I mean, I could write it with some macros as well. By the way, I think you forgot to change the variable from width to height. Oh, thanks. That's... Oh yeah, you're correct. Thanks. So yeah. So again, I think we can take... where did we have that? This. Let's make that into a macro. So I'm sorry about macros, but they are actually useful. So let's call that RGB 888 to RGB 565. And we take RGB and we return again. Let's sanity check. We have the RGB values. We have a starting bracket. It complains because I am missing these. Okay. There we go. Is this readable? I think so. Which library do you use? None. This is 100% 0 libraries. Except for the SDL for the demo. But on the device, we will not use any. Let's see here. I'm gonna read the chat. Yeah, okay. We are back in business. So I'm gonna, yeah, let's say, actually, let's think here. So we have the shape. Yeah, that looks right. So why is it complaining? Oh. Right, so we need to convert this into a color. Actually, wow, I just realized now that this was complete waste of time. That was stupid. Okay. So we need to create a color. So you can create colors or struct instances in modern C. I almost never use this feature, but let's call this just red. And yeah, so we can think about this a little bit later on, but let's just start here. So let's just start simple. Oh, sorry. Okay, again, we want to initialize our shapes. Foreground 1, foreground 2. So let's put this one in 100, 100, and make it 50 by 50, whatever. And then this one at 125 and 125, and also 50, 50. So I hope you see what I'm trying to do here. So I'm creating a background shape, which is red, and then I'm creating a 50 by 50 square at 100, 100 position, and then 125, 125, another foreground. So this one is going to be rendered on top of that, which is going to be rendered on top of that. So let's let's create our tree. So in order to do this, we need nodes. So I wonder if we should have like a macro to create that as well. So let's I mean, now we have shapes, but we don't have nodes for them. So maybe we should have, I don't know. There are so many ways to do this again. So in this case, I'm afraid this is going to be a little bit convoluted to use. So it might be a bad design to do it like this. But essentially that you create separate nodes. So basically what you do is you initialize each node with its shape. And then we need to connect it all together. So first of all, we need to set the previous to null. And then, so obviously this doesn't make sense. We should have like a proper init function for this. Because this is going to be really convoluted to use. And prone to mistakes. But yeah, I hope you understand what I'm doing here. So first, we allocate the space for the shapes. We init them. Then we create nodes that contain a pointer to the shape. And this is not a good design. I don't like it already. But yeah, whatever. Let's start here. And then here I create the tree or linked list where we start with the background and we go forward. And then finally we set the root to the background node. And then here we do okay, so here's the moment of truth. We haven't built this code even once. We haven't run anything. We have no idea what's gonna happen. But I'm curious. So yeah, one thing that is a little bit stupid here is that we don't have any input control. So I'm gonna add that, I think. STL poll event. So I guess I should do this. Down here. And this can be simplified. We can just look at key down and check if it's escape and set a variable like so. We can just keep this code here because we will probably want to use it later on. So again, let's okay, what are we doing? We are rendering one frame. The pointers to the shapes in the list are wrong. Thank you. Points to the node instead of shapes. Thank you. Thank you so much. So this is kind of interesting, actually. Why didn't the compiler complain? Or like, what's it called? VS Code. Because it should have complained, I think. Yeah, it has a pointer to a shape, exactly. Okay. But thanks a lot for noticing, because, yeah. Okay, are we ready to build now? Yeah, we don't check the return value, but yeah, let's ignore that for now. Yeah. Okay, let's build. Okay, it didn't build. Crap. Okay, why not? That is strange. Because I'm including mbui.h and it says I guess it's the order. So Okay, how do you do this? If you have a linked list in C like this, do you have to do like so? This is nasty. So I mean, I'm referencing myself in the struct. I actually forgot how you do this in a nice way. Oh, damn it. I need some C help here. I forgot how to do a linked list where you reference yourself. And so I mean, I want to have an opaque pointer. To the Google machine, I guess. Yep, let's start with the very basics. Okay, so here they actually reference to themselves. Okay. So I guess I can do that. Okay, that worked. So what I did here instead is that I'm using the other style of a named struct. And then I reference, so the name is known in the beginning of the scope, and then I can do the struct thing again. And then afterwards I do the type def, and we can use this in the rest of the code. Stack Overflow says type def struct list. Ah, I see. Right, that was me being stupid. So basically we're putting it like so, and then here right? Yeah. So now we have some other error. Actually, I can build here instead. That way it gets a little bit nicer. Okay, let's fix the warnings. Something is wrong. It returns an... Oh, right. I forgot. Void. Yeah. Implicit cast. Yes, I should have an ampersand. Thank you, compiler. Memset, is that strings.h or something? Yeah, string.h. Okay, it builds. What's wrong here? Destination format. That is an enum. Okay, it's complaining that I don't handle. I should have a default. Yep. No warnings. Okay, now it's getting more interesting. Let's see what happens. Check it out. It actually works. So we get a red rectangle, we get a green one, and a blue one. So I think that's pretty nice. I mean, it's not advanced in any way, but we have something. So yeah, first try. Yeah. So I mean, I had some compilation errors where I needed to add some ampersands. Oh shit. Memory leaks. That's SDL probably. Yeah. No, it feels great to actually that I didn't have any runtime issues. That our rendering was actually correct and so on. That was nice. But I mean, it's thanks to you telling me that I'm doing wrong stuff, and the Visual Studio Code telling me I'm doing something wrong. So yeah, it's easy mode today, which is nice, of course. So how do we want to proceed now? Should I perhaps clean up this weird malloc error? So I'm not that familiar with SDL. It's probably the frame buffer that I'm leaking. Do I need to like destroy the texture or something? I'm doing create window, create render, create texture. I probably need to do everything in reverse. So is there something called SDL delete texture? Destroy texture. Okay. Good documentation. That's nice. And we just need SDL or FB texture. Okay, cool. And then what about the renderer? Destroy renderer. Okay. And then create window, destroy window. Okay, perfect. And then finally SDL quit. I don't know if we need that. Maybe, maybe not. Oh, it's complaining. Right. Init window. Oh. Yeah, that's known. Yeah, check it out. No memory leaks. Perfect. So now we have a pretty good baseline. So I want to fix this error. So I'm gonna just do assert res equals MEUI. Okay. Yeah. And then, yeah, that should be good. Oh, still complaining. Didn't I include assert? No. Okay. Okay, no warnings. No warnings. Nice. Now I'm actually happy. Like, this is a good, really good baseline. It's far, far, far away from done. But let's commit this. And nice. Licenses. Which license should I choose? GPL v2, MIT, BSD. I usually don't care much about licenses, but it's good to have it. I don't know. Something permissive. Yeah, it's good to have one. Yeah, I think so too. So let's go for, I don't know, BSD 3 class. MIT. Yeah, I honestly don't understand the difference. Like, I think it's the third clause here. Neither the name of the copyright holder nor the names of its contributors may be used to endorse or promote products derived from this software without specific prior written permission. As is, no warranty, whatever, do whatever you want. Yeah, I honestly don't care. Cool. So yeah. All right, here goes. Yep, it's far away from done. So let's go. And then I have to go to GitHub, I guess. 1 second. All right, sweet. So it's live. I hope I didn't misspell. Cool. All right. No, but this has been fun. Writing code from scratch is fun. So the question is, where should we go from here? Should we try to figure out this stuff? I didn't quite like it. It would be nice to reduce the complexity. Like, this is not nice to use. I mean, we could actually incorporate the node, like the linked list stuff, inside of the shape, so that this becomes a part of the storage class, so that let's say that everything is a shape, then we can just do like so. And then do like this. But that gets nasty. Or actually not, no, because if we go for the image again, then that will contain the node information. I mean, or we make it, yeah, okay. See ya. Nice that you hung out. So I mean, we could place the node stuff like here, and not have any storage, and then we just put the node like so, so that, yeah, so this way you can always sort of like, if you have a pointer to a node, yeah, I don't know, there are so many ways to do this. But yeah, this is probably a little bit nicer. And then, yeah, let's fix this. So this way we don't need to do this. And instead of the node underscore, we just go for like this. And a node and a shape is basically the same pointer-wise. But I guess I can, just to be nice, do like this, even though offset, like the pointer value will be the same. So this can all be handled in sort of a nicer way. Why is it complaining though? All right, because I need to do. Yeah, okay. So I'm just gonna do this explicitly, just so we have something that works, and then I can write a macro for this, so, or a helper function, so it gets a little bit easier to use. Right, so here we have to cast, yeah. Mm. All right, just to explain what I did here. So here I'm casting the node to a shape. And I can do that because the first entry of the struct is a node. So they can be cast back and forth. Let's see if it runs. Okay, it broke. So I probably messed up something. Yeah, I don't know. Casting back and forth is a little bit dangerous, of course. But I don't understand here really. It should work. Okay, so it seems that the type gets messed up a little bit. Probably because of some alignment issue. Oh no, I'm being stupid. Yeah, this is why casting back and forth is bad, and using C++ is better. But yeah, I wanted to use C because it's simple. Yeah, shouldn't really be doing this casting stuff, but it's nice to have like one full container class or a container struct that contains everything you need. So I mean, right. So the issue is that because our enum is 16 bits, I guess it gets a bit messed up. The node type here is only 16 bits. So because I'm on a 64-bit system, I guess it looks like this. I have the big pointers here. I'm thinking that maybe it's an init thing. I'm gonna try something. Maybe these contain crap data from the stack. Yeah, look at this. Now it works. Okay, so the reason to the issues that we had just before was because I used stack pointers or stack allocations that were not initialized, which means that the container contained junk. And yeah, that's bad. But I'm gonna try something new here just to be sure. So I'm not just thinking that it works now. So by starting the enums at 1, I force it to, yeah, okay, it still breaks. That's good. So the reason why it seemed to work was because the shape enum was set to 0. So my mem set. So I mean the issue is that I'm basically reading from the wrong place because of the size of the enum. And yeah, I guess this casting is dangerous. Hi, slightly off-topic question. I saw you're using DTCM and ITCM memories in the project. Did you explain why in the video? No, not really, but I can explain. So here's the RetroGo project. And here are the different memory areas that we have. So the ITCM, it is meant to be used for instructions. So you put code here and execute from it. And DTCM is meant to be used for data. And then there is AHB RAM. Yeah, that's the AHB RAM at a different place. And then there's the AXI RAM on a different. So these two memory areas, they are being accessed over a bus, whereas these two are tightly coupled. So there's no latency at all. They are immediate. When you access memory from this, you get the memory directly. There is no penalty, no delay at all. So the reason why you want to use these is because they are faster. However, they are small. These are larger. This is 1 megabyte and this is 128K. So the reason why you want to use these is because, yeah, they are faster, and but they are limited. So yeah, that's why. But you are free. It's actually possible to put data in the ITCM RAM and put code in the DTCM RAM if you want to. It's actually it works. There might be some slight issues with that, but I haven't had any problems with it, so I don't know. Seems to work fine. So does that answer your question, Carl? All right. Oh, I just realized I don't actually set the shape type. Okay, now it works. So I'll probably keep this at 1 because that's actually a pretty good thing to do, to initialize your enums with the 1, because then 0 can be sort of a failure that you can check for and assert for. So Yep, and here we go. Okay, now the pointer stuff works. So there was never a problem with the pointer. The issue was that the data was initial. So when an enum might be optimized to become 16 bits or 32 bits or whatever, something that is smaller than you expect. But when you read it, if you're unlucky, you might read the whole 32 bits. So if there are any bits that are set, it craps out. So I think that's what happened here. That would, or actually, maybe not. I'm actually gonna take that back, because that shouldn't happen. So I'm gonna remove the init stuff and try again. And now it works. Okay, so I take that back. So the reason why it didn't work before was because I simply had forgotten to initialize the type in the macro. So there you go. There was never some magic, compiler quirk or stuff like that. I was just being stupid. But yeah, there we go. And so using this different method of casting the node to a shape and then operating on it, we are able to cut quite a bit of code, and we can do this cleaner. So yeah. We can add a convenience function. Let's call it node append, where we take what should we call them? You want to append a node to another node. I'm really bad with names, because you don't really have a root. You maybe node and then new or next, yeah. Maybe that's good. So you append next to the node. Yeah, I think that's good. Then let's implement it. So yeah, should I call it insert? It was a long time I wrote stuff like this. I want to kind of follow conventions. Let's just look for some bog standard API. Right, because here you have like an object for the whole list as a concept. But we are only operating per element. I don't know. Let's do insert, where you put a node after the node. And if the node has a next node, we will remember it. So if it's null, we will just set null here. It should be fine. And there we go. Yeah, still works. Right, should remove this. Yeah. Yeah, so the question is if we want to do something smarter about the colors, because it gets a little bit convoluted to have sort of a container class, like a struct like this. It also wastes a lot of space. I don't know. Let's leave it. I guess you can have a union. I think this makes sense. So you can get the value as a uint32, or each channel, if you want to access them. This way, you should be able to just use a 32-bit value. So, yeah. All right, little endian, big endian, always gets you. Yeah, okay. Nice. I think maybe this is a good place to end the stream. We have something that works. We can draw some rectangles. Next step will be to do alpha blending, which I'm not gonna do right now. And then later on we will port this to the device so that we can see this running on the device. And then we can add features such as animations and images, and then font rendering, and then we're done. So I think I've spent like 3 hours now on the stream, and yeah, it's been mixed, but I think we have a good foundation. So yeah, thanks for joining, and see you next time. I'm just gonna commit this and then we're done. Okay. Yep. So thanks again for joining. Bye.